problems like this where I have 2 over the square root of 7, and we just do what's called rationalizing the denominator, where we multiply by root 7 over 7. So I get 2 root 7 over 7, okay? We've done that. Now, what if I have something in the denominator where I'm adding a whole number? So negative 3 plus the square root of 7 is in the denominator. What we're going to do is multiply by the conjugate, okay? And the conjugate is a fancy word for the opposite in the middle, okay? So you only change the middle sign. So I have a negative 3 here, and I'm going to multiply by negative 3 minus root 7. And the same thing in the numerator, negative 3 minus root 7. Okay, same thing on top bottom because I'm really multiplying by 1, so I'm not changing the value of it. But what happens when we multiply by the conjugate, and you might want to make note of this vocab word, conjugate, is we're going to end up with all whole numbers in the bottom. We're not going to have radicals anymore, and that's the goal, okay, is to get rid of the square root of 7. So in the numerator, I multiply the 1 times each of these, which just gives me negative 3 minus the square root of 7. And we're allowed to have radicals in the numerator.
Why is it only one number?
Okay. And in the denominator, we're going to FOIL. Okay. So I've got negative 3 times negative 3, which is positive 9. I've got negative 3 times negative square root of 7, so that's plus 3 root of 7. And then my inside, I have a positive root 7 times a negative 3, so that's negative 3 root 7. And last, I have plus the square root of 7 times minus the square root of 7. So that's negative square root of 49, which is what?
7.
Right. So if you want to just put 7, that's fine. I'm just doing it as 7. Okay. And what's really cool is what happens to the middle terms. Yeah. I have a positive 3 root 7 and minus 3 root 7, so those cancel. And then this turns into 7, right? So here I'm just going to have a minus 7 instead of the square root of 49. So my numerator stays the same, negative 3 minus the square root of 7. My denominator now I have 9 minus 7, which is
2.
That's the answer.
And that's the answer.
Well,
Okay. Alright, so go ahead and write this one down.
Are we never square roots in the numerator too?
What'd you say? Oh, cancel the numerator? No, just the
I mean,
denominator.
like 5 square root of 4, not 5 root square root of 5 over. Is that what you do?
Yeah, you got that. Good. Okay, so we're going to do the same thing. We're going to multiply by the conjugate, which is the opposite, just in the middle. Alright? So that means that I have 3 root 2 minus root 3. And the same thing in the numerator, 3 root 2 minus root 3. So the numerator, we're going to distribute this to this, this to this. And remember the outside numbers multiply together, so that'd be 15 root 2. And minus 5 root 3. And we're going to FOIL the denominator. What is always going to happen with our middle terms when we FOIL conjugates? They're going to cancel, okay? Because I have plus minus, the exact same thing, I know that the outside and the inside are going to cancel. So if you want to skip a step, really all I need to do is multiply the first times the first and the last times the last. Make sense? Because my middle terms will cancel. All right, so let's multiply 3 root 2 times 3 root 2. So the outsides multiply together to be 9, and the insides multiply together to be 4. If you want to put 18, that's fine. Okay. And my last multiply together Don't miss the sign, okay? It's really important that you're multiplying a positive times a negative, so you're getting minus root 9, or you can just put 3. Okay, so now I have 15 root 2 minus 5 root 3. And in the denominator, I have 9 times 2 here, which is 18. And I have the square root here, which is 3. And so I end up with 15. Okay, does that look like something we can simplify further? Yes. What do you notice every number is divisible by? 5. So you can reduce it by either factoring out a 5 from the numerator. So if I factor out a 5, that would leave me with 3 root 2 minus root 3. And then reduce those outside numbers to 1/3. Okay? Or I could just, in my head, divide this by 5, divide this by 5, divide this by 5. And 3 reduced 2, 3 root 2 minus root 3 over